Welcome everyone to the latest podcast edition, Reimagine Mobility. I'm here with Thomas Glatz, and he works in our Advanced Simulation Technologies group, where we do a lot of simulation tools, products, and supporting our customers with simulation needs. Welcome, Thomas. Thanks for joining me. And let's start right out. Let's talk with fuel cell technologies. We had several different podcasts about fuel cell technologies. And in all of those, I usually bring up simulation because it's, in my opinion, one of the key enablers for the future of mobility and reimagining mobility that we're really talking here. So a key enabler. What do you know about simulation for fuel cell systems? What do you see the key advances, the key points? Tell us a little bit about it, and with it, obviously, what does simulation mean to you?
Absolutely, yeah. Thanks for having me, Stephan. I think the first time I got in touch with fuel cell simulation in AVL was pretty much almost 5 years ago, where we started to do simulation in our tools in the system simulation side, in CruiseM, also in the 3D CFD side in FireM. And ever since then, it's a big part of the development process. It can help in so many ways. It can start at the beginning, design, balance of plant modeling, different variants, all down to the component design, to the details where it can help the model, the details of the component of the stack, but also of the so much more than just the stack, especially for the solid oxide fuel cells. It's a balance of plant, all the auxiliary components, the catalysts. Here simulation definitely can help. And obviously also towards the virtual testbed, the hardware in the loop applications, the control strategy development. Here simulation is key to just cut down the time and just the effort also. Automatize, parallelize. Sure. Yeah, that's.
Mm-hmm. You mentioned SoFC, AVL specific. I think at least on the stack point of view, we're heavily focused on PEM. But obviously on the complete propulsion system or power plant, we do anything and everything when it comes to fuel cells. So like SoFC, PEM. Is there a difference when it comes to simulation? Is one more important than the other? I mean, is one simulation type more important for one or the other, SoFC or PEM? Is it equally important? Is one giving you more benefits, less benefits? Highlight a little bit in that regard.
Yeah, as you said, we do both, and it's for us from development side and also from product side. I'd say it's equally important. It's definitely different aspects. So what you focus on the simulation side. So on the SoFC side, it's much more about the balance of plant, the auxiliaries, the entire system, also heat regeneration and real power plant, so to say. On the PEM side, it's much more about the vehicle integration, also durability, especially when it comes to track applications, for example. Aging models, durability models is a huge factor. Here we have a really good offering, I'd say, which is quite unique. On the SoFC side, we are developing aging models, degradation models there, but it's much more for stationary application, much less transient, so not that of an important factor, but getting more and more important there as well.
Okay. Interesting. So you clearly mentioned there's different applications for different sorts of simulations or different technologies using simulation. If you could give the listener, including me, an idea, how are customers using simulation today that may be different from, you mentioned you've been in this for 5 years, from maybe 5 years ago. Have you seen a trend of changes, how customers using it? Maybe, to me, simulation when I first started was very little, right? And then we started using it sort of on the side. And today it feels like it's one of the main activities. Is this similar in your experience, or what do you see?
Absolutely, yeah. When we started developing the fuel cell models, it was basically an R&D project. It was a lot of R&D work. It was like small groups, specialized groups doing this. But now in the OEMs and also in our customers and the tier ones, tier twos, it's a real product, and it goes a very similar route than it went for conventional engines and aftertreatment, and all the learnings we had with AVL. We are now at the point that we actually transfer all these learnings and using not the exact same, but in a very similar transferable manner. We're using the models now with hardware in the loop, all the learnings we had, and there were a couple of hard learnings over the years we had to make. We don't have to do now again. So we're in a really fortunate position here as AVL to use the models there. And from a process and integration wise,
You're also doing simulation for battery. We're doing simulation for e-motors, e-axles, ADAS, lots of different things. If we take battery, right, which clearly any fuel cell powered vehicle or even a stationary application, probably in most cases includes a battery. So let's maybe jump to batteries then. Tell me a little bit, are there differences between the simulation used for fuel cell? Maybe because, again, you said the whole power plant, maybe certainly for SOFC, as opposed to maybe battery that's more maybe focused on a cell or on a module or on a pack. Can you shed a little bit of light on that?
Definitely, yeah. So for the battery, and as you said, I fully agree. Every fuel cell vehicle is a battery electric vehicle. So just the power that comes from the fuel cell, but you need the battery to drive the vehicle in a sort of manner. From a modeling perspective, with the fuel cell, you have to care about gas dynamics. You have to care about liquid. This is all not so much the case with battery. With battery, it's basically the electrical network and the cell chemistry. And this is the core modeling part in combination with the thermal part, which is outside the cooling, which is a big factor. But yeah, you don't have to really model all this gas dynamics or flows. So it's kind of a different but similar perspective to modeling.
Sure. Yeah. Okay. Where simulation, right? As I think both you and I agree, simulation has come a very long way and is today probably 3 times as powerful as it was just even 5 years ago. I would guess for a moment. You know that better, but I would guess. Where do you see simulation going from here? Is it a proportional? We continue that progress with double or tripling the capability every 5 years? Do you see it somewhat leveling off? Share a little bit about what you see and what it may or may not depend on.
I definitely don't see a level off. I see a strong focus and progress on the simulation tools. It's the only way really to cut down the development time and also cost and manpower especially. With all the autonomous driving, ADAS especially also, and all these different configurations, possibilities and variants. Do you use a fuel cell? Do you use a battery? What size? How do you combine all these new possibilities? It's so much variance, you just can't handle it without simulation tools anymore. So this trend will strongly continue, and also with our aerospace and outer space variants and activities we are all doing, there it will even continue more. So I see a very bright future for simulation. Okay. Maybe something more personal for you here. What excites you about simulation? What made you decide to work for our Advanced Simulation Technologies group and be clearly, as I can tell, excited about simulation, the possibility, how you and with your product and your team helps, again, reimagining mobility, shape the future of mobility today through simulation capabilities. What excites you about simulation? Yeah, one of the greatest things about simulation, in my opinion, is that you can actually observe and see and research stuff which you are not able to measure in the real world. So this is like really the one thing which I say, okay, this is super cool, because for example, the battery, you take it with simulation, you can observe what is going on inside without having to destroy it. Or actually there's stuff in there you cannot really measure. It's super hard to measure. It's not feasible to measure it in a vehicle, but with simulation you get that insight. You can avoid this durability issues, this strains and conditions which really damage the battery just by looking at on simulation results. And yeah, this is really great about simulation.
Yeah. When you look at simulation and you look at your industry and your products, or just generally speaking, the simulation industry, what sources do you use for you to get information? Where do you get information about new developments in simulation, right? How much closer are we for a correlation between what's happening in the real or physical world versus the simulated world? Is there a specific place people can go to because you're going to and getting your information there? You read a certain set of books, you go to certain trainings, I don't know. Can you share a little bit on that?
Yeah, so first of all, we are in a very fortunate situation with AVL that we have a powertrain engineering department, we have the measurement in-house, we have the test equipment in-house. So the first place where we can go is like internally, coordinate with the engineers. We get a lot of feedback from the users on the engineering side. We get requirements from the measurement side. We get new developments there. So this I would say is one major source of information. Then of course we work closely together with universities, with research facilities to get the new trends, and also we constantly educate us further. For example, I just was on a 2-week battery training in Germany on a university course, like going back to school basically, to like really deep dive the knowledge again. It was not just me; it was the entire battery development team from Glatz and all over the place of AVL, all over the world. So yeah, these 3 pillars, so to say, are really what we get our knowledge from, our ideas, and also create new ideas. Yeah.
So continuing education, right? As we all know, we're never done learning.
Absolutely,
we're no longer here, probably. So that's good to know. If you take a project, let's say that we did with a customer segment, let's say passenger vehicle OEMs for the moment, 5 years ago, and you look at how important was simulation then, or how widespread, how strong of an adoption did simulation have then, let's say for fuel cell development, and how much is it now? Independent of that, maybe fuel cell now is finally at the point where it really is gonna take off, not like it's been for the last, let's say 10, maybe 15 years, just being around, but never really got a kick and really that boost that I see personally now happening. But if you take that 5 years, how do you see that changing of how critical for an OEM is it fuel cell? And maybe passenger vehicle OEMs are not the right one. Let's go heavy duty trucks, probably a better application. But what do you see? How critical was simulation for them 5 years ago versus what it is today?
Oh, it's massive. So to give you a number, for example, in like 5 years ago, we had like 20% of our test benches, for example, were virtual. And now we are at 40%. So 40% of the test benches, what we have in AVL is virtual. That means all of them are running on models, and this just it basically showcases how much the simulation factor has grown in the project. And I mean, this is the number which is really the calibration engineers, the late in the development process. So you can only imagine how much more simulation has grown also in the beginning of the development process. The design, as I mentioned, so much more variety, complexity is now there, and especially the new technologies, battery, fuel cells, simulation is just kickstart.
Excellent. All right, I got 2 more questions. So from a technical point of view, or from your experience dealing with customers all over the world and now in the US as well, obviously, what do you see as one of the challenges that you feel customers still maybe don't recognize you can do with simulation, or maybe not use simulation to the capabilities it is capable of today? Maybe it wasn't 5 years ago, but it is today. Anything there that you can share is like, hey, I wish customers would understand that this is more powerful here, or use it better here. Just maybe something to highlight here.
That's exactly what we also see when we go to customers, and very often there's just kind of a tunnel vision what you can do with simulation, but in reality it's much broader what you could do. Like there's so many things you can do and can try. And to give you one example, what we are currently working on is to use our simulation tools to bring to the customer for his sales activities. So actually he can bring our software to his customers and on the fly use it to generate the best the best configuration based on the customer's input. And so basically you use, for example, a simulation tool kind of as a sales tool to a certain degree. So that can be very interesting. Of course, there's much more. We very often see just limitations like in the view of the customer what we can do, but actually we can do much more. Let's say for battery, the focus is still much on equivalent circuit models. But with electrochemical models, you can already do so much more, and it's just not yet there in the awareness. Or also, the awareness is not there. But it's our job to make this awareness happen. So we're working hard on that.
Right. Good. All right. And last questions. I've heard you played basketball in Austria.
Yeah, that's correct.
So I play basketball in Switzerland, so we have something in common. But we're interested from you. What did basketball teach you about whatever the business world, or teach you about maybe even simulation, right? So anything to share there from that perspective?
Yeah, I'd say even life to a certain degree. But of course. You simulate. I mean, every practice is a simulation of a game, ideally, if you do it correctly. Yeah. So, I mean, that's what you practice for. So in the end, it's you want to compete, you want to win, and that's the same what we do in the business world. So it really told me a lot, especially also teamwork. I'm basically, my approach to basketball is very prioristic. So. I'm not too much about the show. I'm about the team. So that's what I enjoy. I played for 18 years. I'm still on the roster in Austria, but obviously hard to play right now. But hopefully I can do my 20 years at some point.
That's cool. Very nice. Yeah, I love it. All right. Thomas, thank you very much. Very insightful, very interesting. Again, simulation, for me, one of the key enablers of the future of mobility, and maybe even the sole tool or enabler of how do we truly reimagine mobility, not only on the ground, but in the air, and as you kind of alluded to at one point too, in space. So thank you very much, and thanks everyone for tuning in.
Yeah, thanks for having me. Thanks.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.